Okay, see. See. So in the chapter sound, in the last class, we had studied a few definitions, right? We were studying mainly about the oscillation. See, in the waves, we had observed that there are two types of wave, and wave is a nothing, but it is a type of oscillation only. It is a type of propagating oscillations. When the oscillations propagate from one place to another, then we call that as the wave. Okay? Or a wave is also called as the disturbance. A disturbance in a medium is called as a wave. Okay. So please, all of you turn on your cameras. Uh, Sound. And here we are mainly doing about the oscillations. So in the terms of oscillations, I had defined you some of the terms. We had seen a few terms. Okay. So you will be giving me out from the diagram. I will also draw the diagram and you can give me out from the diagram. Amplitude. Then we have studied about time period. Then we have studied about oscillation. Then this is the term which we have not studied, that is frequency. Okay. So these are the four things we need to understand from the oscillation. Then there are two other terms which we need to understand from the wave. Okay. Since in the wave we observed that there is nothing but oscillation. There is oscillation of the particles. And we observed that the oscillation of the, if the oscillation of the particles is perpendicular to the direction of the vibration, then if the oscillation of the particle is perpendicular to the wave propagation, so such a wave is called as a, what type of wave we call that?
Longitudinal wave.
It is perpendicular, then it is a transverse wave. And if the vibrations are parallel to the direction of propagation, then it is a longitudinal wave. Okay. And we had seen the differences between them. So first of all, we see oscillation and then we will see apply this oscillation in the wave, how it is in terms of wave. Okay. So here we have the simple pendulum. This is the mean position O. Here, what's the name is given to position A and B?
Extreme position.
Extreme positions. Very good. Which energy is there at position A?
Potential energy.
Potential energy. Very good. And which energy is there at B?
Kinetic energy.
At B. At B.
Potential energy.
Yeah, at B also potential energy. At A also potential energy. And at O,
Maximum
No
kinetic
energy.
energy.
it has the maximum kinetic energy.
Oh, okay.
And in between, anywhere in between, what will be the energy then?
Both the energies.
Okay. And in the exam, I think in the subjective test, I have checked all our notebooks. I found one of the person, I think Harini. Harini had submitted only one page. Yeah, Harini,
Yes, sir.
did you submit only one page for the test?
No, sir.
No, in the test, actually only one page was submitted. So that is why your score was the least. Okay, so from next time, take care, make a PDF and send the PDF file, not the JPG file.
Oh, sir, I sent 3 JPG files, right?
Yeah, so there were only one uploaded. So that is why I send always PDF. No JPGs.
Oh, okay, sir.
Okay. Attach the PDF file. Okay. So, okay. Good evening, Neil. And someone is not here. I think, okay, all of you are there. So in this term, what will be the amplitude? Which distance will I call the amplitude? Can anyone tell me? Which distance will be called as amplitude? Siddharth, which distance shall I call as amplitude then?
Sir, I wasn't there when you told this topic.
Which one? Which
Sir, I
one?
wasn't there when you told this topic. I was absent because
Okay. Anyone? Siddharth, can you tell me which distance will be the amplitude? See, in the last class, I made you understand using some other diagram. And that diagram was a string. We took here a string. Do you remember? In the last class, we had taken a string. And if you pluck the string from between, so to pluck it, you have to move it to a certain distance to one of the sides. Suppose I move it over here to this point A, and then I release this. So it passes through the mean position and passes to the other side. Okay. So this point passes to the other side, which is B, and hence the string keeps on vibrating between the two positions A and B. This is the middle position O. Okay. So Prince, were you present in the last class?
Yes, sir.
Okay. So I told you this term amplitude. Do you remember? Anyone remembers amplitude?
The distance between mean position and the crust or trough, I guess.
Uh, Leave that crust and trough for now. Since crust and trough is what we have for the wave. Amplitude can be defined for any oscillating particle, and a wave consists of the oscillating particle. Okay. So what is amplitude? It is defined as it is the maximum displacement from the mean position. Okay. So we will see what is the mean position. Here we can see that the point O is the mean position and A is the extreme position. So AO I can call as the amplitude, right? Okay. Here in the string also I can call the distance AO to be the amplitude. Here my AO will be the amplitude. Okay. Then in the last class I discussed about oscillation. So who remembers about oscillation? What is one oscillation?
Sir, one complete to and from motion. So
Okay,
all
very
from
good.
motion is
Very good.
called.
That means you are paying attention. Very good. So one complete to and fro motion. So one complete to and fro motion is one oscillation. Okay. Then we discussed about the time period. Anyone? Pranaya, what is time period?
The time period is basically the time taken for like the object to make one oscillation.
Okay. Time taken to complete one oscillation. Time taken to complete one oscillation is called the time period. And we had obtained this. We had done one question. Do you remember that question? Time taken to complete one oscillation. I had given you time for 20 oscillation. You found out the time for one oscillation. That is the time period, right? Then frequency. So frequency is defined as we define frequency as the number of oscillation the number of oscillations per second. Okay. How many oscillations it is making per second, that we call as the oscillation. Okay. So very simple definitions are there. Here, if we see, suppose we want to find out the frequency. So if we represent frequency by the symbol f, so I can write frequency will be equal to 1 by time period. This is a very fundamental relationship between frequency and time period. Okay. So frequency and time period. Time period is the time taken to complete one oscillation. Number of oscillations per second is called frequency, and it is measured in the units hertz. Okay. So SI unit of frequency is hertz, right? In your books or in most of the book, you will find not the symbol F, rather you will find here the symbol nu. Instead of F, you will find the symbol nu, which is made something like this. Okay. Nu represents frequency. So you can write nu equals to 1 over T. Okay. So let's try to find out the frequency also. Okay. So to find out the frequency, first we complete the time period, compute time period, and then we compute the frequency. Okay. Let's see one question to compute the frequency, and then we will move towards the wave. You see, a tuning fork completes 200 completes 2000 vibrations in 5 seconds. Okay. So you have to find the time period and frequency. Okay, so start solving. Let's see who obtains the answer first. So you have a tuning fork. It completes 200 vibrations or 200 oscillations in 5 seconds. So use the unitary method, find out the time period, and then compute the frequency. Okay, anyone obtained the value of time period? Is there anyone who has obtained the value of time period?
So 400?
400. Okay. Yes, the time period is 400. So 400, what will be the unit of the time period? Yes, Harini, what will be the unit? Pranaya, did you get the answer?
So 400.
So
Okay.
will it be seconds?
Yeah, it will be a second, since you are finding the time period, and time will be second. See, so first we write the time taken for 20 vibrations, and this is equal to 5 seconds, right? Then you find your time taken for one oscillation. There is no direct formula. You need to use your unitary method, remember. Okay, I got three answers. Just tell me the frequencies also. Three people have sent the answers and they all have sent the time period. Is it the time period? Let's see. It's not the time period. 400 is not the time period. Time taken for one oscillation. What will be the time taken for one oscillation? See, remember this. Always make the statement. Do not go to shortcuts. Make the statement. You have to find the time period, and time period means time taken for one oscillation. See, so time taken for 2000 vibrations will be 5, and time for one will be 5 divided by 2000. So what's the answer?
1 by 400.
1 by 4.
Yeah, you get here answer as 1 by 400, right? So your answer is 1 by 400 second.
So then 400 is the frequency, 400 hertz.
Yeah, then frequency is 400. Okay. So then you write frequency equals 1 over time period. And this will be equal to your 400. So 400 unit will be hertz. So is there any difficulty in these questions? Very simple, but you are skipping the steps. That's why you are getting the wrong answers. Right? So I hope you will not skip the steps. Okay. See, 400 hertz frequency is the frequency what we can hear. So if you will be able to hear the vibrations, you will be able to hear a sound coming out from the tuning fork. Okay. Let's see now the wave part. This was about the oscillation. This much you should be knowing. Okay. If anyone has any doubts in this calculation of the frequency, please clarify your doubts with some questions. Okay, try to solve some question or ask some questions so that this topic is clear. Frequency, time period, amplitude, vibration. Okay, I want these four things to be clear. The next thing we do about the wave. What is a wave then? And how we represent the wave. So as discussed in the last class, wave is a disturbance in a medium. So how we define wave? Any disturbance in a medium is called wave. So it is a disturbance in a medium that propagates through distance and time. You can also write like this. Any disturbance in a medium which propagate with distance and time. So what I mean by this? Let us try to represent a wave. See, wave representation, we are not drawing the diagram of how it is moving. We are drawing a graph. First of all, have an idea in your mind that we are drawing a graph. Okay, this diagram we are drawing, this is the graph. So we take here graph, we try to plot a graph. Okay, and what is this graph plot for? This is your x-axis. We have taken this as the x-axis, this one as the y-axis. Okay, and this is your time. On the x-axis we plot the time, and on the y-axis we plot the amplitude. Okay. So what we are plotting actually? Do you know what we are plotting? We are plotting here the amplitude versus time. That means we have not amplitude, rather let's say it's displacement versus time. Uh, okay, let's have this be displacement. So we have this displacement versus time. Okay, so on the y-axis we are plotting the displacement. On the x-axis we are plotting the time. Okay, so how will it see any oscillating particle? Like if we see the oscillation of the pendulum, the oscillation of this string, it is always confined between two extremes. Okay, and we can consider one of the sides to be positive, the other side to be the negative. Here also we can consider this side to be the positive displacement and this side to be the negative displacement, right? So we can represent a wave something like this. Over here a wave can be represented like this. So this is a graph of the wave. This is a wave representation. This is not a wave. It is a representation of a mathematical representation. Okay. See, this line X, it represents your mean position. Okay. So if the particle is from the mean position, it goes up and then comes down. Again goes up, again comes down. So just the pendulum, if you see the pendulum, first it goes towards right, then comes towards left, goes negative, again goes. So in this way it is moving. So this type of motion is represented by this graph. And hence this maximum displacement that you see, the maximum displacement over here will be called as, this displacement will be your amplitude. Okay. So maximum displacement from the mean position O to the maximum extreme position A. Here AO will be the amplitude. This one is the positive amplitude and downside is the negative amplitude. The upward vibrations, they are called as crest. The downward vibrations, they are called as the trough. Okay. So what's different in wave? You have another term, wavelength. Let's see, wavelength. So what's the wavelength? Wavelength, it is the distance between two consecutive crests and or two consecutive troughs. Okay. So what is a wavelength? A wavelength, it is the distance between two consecutive crests or two consecutive troughs. So let us see from the diagram which thing can be called as the wave. Okay. So the distance over here on the graph, if you observe, uh, here from A, so let's see, from this position A to the next higher level over here. So this displacement, this distance between these two extreme positions, these two crests, we call as the wavelength. Let this be B. We have the distance AB equal to the wavelength. This is your wavelength. It is denoted by the symbol lambda. Just the symbol is lambda. And what should be its SI unit? Can anyone tell me the SI unit of wavelength?
Meters?
Centimeters.
Meter. It's in meter. It is a length and length is measured in meter in the SI system. Just 1 minute, beta. 1 minute. Okay. So see, wavelength, it will be SI unit. If you are asked, it is in meter. It's very easy to remember. See, it is a type of length, and length SI unit is meter. So we are measuring the distance between 2 points A and B. That distance is meter. Okay. So understood the term wavelength? This is a new term introduced in this chapter, wavelength. Okay. Nothing else. The symbol is lambda. SI unit is meter. So a wave which characterized by its wavelength. Okay. Now let's see what are the other things over here. You have the wavelength. Then other things that we need to know here. Wave velocity. This is also important. Wave velocity. So what is wave velocity? It is the velocity with which wave propagates. Okay. The velocity with which the wave propagates is the wave velocity. And since it is velocity, so what should be its SI unit?
Meter per second.
Yeah, its SI unit should be meter per second. So it should have the SI unit as meter per second. Okay, represented by the symbol V. So V will be represented in meter per second. Okay. Now let's see some relationships. A very important relationship from this chapter, that is a relationship between wavelength, wave velocity, and wave frequency. Let's see. So these are some of the technical terms that you should know. The relationship is here only I'm writing. Relationship. This is a very important thing. It stands that V is equal to nu lambda or F lambda. Remember, this will work a lot for you. So the wave velocity is given by frequency into frequency into wavelength. Okay. Understood this topic?
Yes.
Okay, fine. So see here, the wave relationship between wave velocity and frequency wavelength will be given by V equals to nu lambda. And with this, now we continue further. These are some of the terms which are important for your exams. Whenever you are going for the exams, remember these definitions. Wave, wavelength, wave velocity, frequency, time period, oscillation, all these things. Okay. Now again coming to the topic sound, and how does the sound propagate? See, how does sound travel? Okay, so how does sound travel in air?
Through
Just like
vibration.
just like we observed in the case of spring, just like we observed in the spring, there are some regions where we see compressions, and there are some regions where we see rarefactions. Okay, so here the spring travels in the spring, the wave travels in the form of compressions and rarefactions. Okay, so in the air, how can we explain this in the air? Let's see, if I draw the diagram, it will take me a lot of time. Rather, take me the help of your book and try to understand how the sound wave propagates. Okay, propagation of sound. You see, this diagram, it fairly represents how sound waves travel through air. What's the name of this instrument that you see here? Can you tell me the name of this instrument?
Fork.
Which one?
Tuning fork.
Yeah, this is the tuning fork. When you strike it at any surface, so these two forks, they will start vibrating. Okay. When they start vibrating, so they will vibrate the air near. How they will vibrate? It will strike the air molecules and the air molecules will get compressed. Since air is a gas, so the molecules of this gas will get compressed. Okay. When the air molecules get compressed over here, then they again try to expand. When they try to expand, they compress the other regions nearby. They compress the rarefactions nearby. Okay. So in this way, the sound wave travels in the form of compressions and rarefaction. Okay. So this diagram is important if you are asked that how the sound wave travels. So this diagram is important over here, that sound wave, it travels in the form of compressions and rarefactions. Okay. So the answer to this question will be the diagram. Along with, you can say it travels in the form of compressions and rarefactions. Okay. So sound wave, it travels in the form of compressions and rarefactions. Now let's see the speed of sound in air. What is the speed of sound in air?
Around some 340 something meters per second.
Yeah, the speed of sound in air is nearly 340 meters per second square per second. The speed of the sound is 340 meter per second. And the next topic that we'll see is echo. So what is an echo? And persistence of hearing.
So when you speak and the voice hits a hard surface, it reflects back.
Okay. So that we
And
call as the Hmm.
if the distance is more than 340 meters, if the speed is more than 340 meters per second, then our brain can process it because then it will be more than 0.1 seconds. So we can hear the echo. Then it's called echo.
Okay, so you are pretty close, but you are not completely clear. Okay, so first thing we need to know here, persistence of hearing. Okay, so the persistence of hearing, it means the time for which any sound persists in our ears. If you hear something, so for how long that sound will remain in your ears. Okay, so the effect of that sound will be in your ears for about 1/10 of a second only. After that, you can hear the next sound. If you hear another sound before that time, so you will not be able to differentiate between them. And this is the reason that when many people are talking nearby you, you can't hear to all of them. Can you distinctly hear to all the people?
No, sir.
Unless you are a superhero, you can't hear. Only the superheroes like the Spider-Man and others, they can hear what the others are talking. Everyone is talking, they can hear everything. Okay, but we can't. This is the persistence of hearing. That means the time for which the time for which sound persists in our ear. It is in there in our brain, but not in ear after that. Okay. persists in our ear. So if you hear any sound before that, you will not be able to differentiate. Okay. So on this basis, in the similar way, can you tell me what is the persistence of sight? If you see anything, so for how long it will remain on the retina of the eye? For how long will it remain on the retina of eye?
So,
Tens of a second.
isn't it 1/16th of a second?
Yeah, for the sight, it is 1/16th of a second, and for sound, it is 1/10th of a second. Okay. So if another sound is produced, if a number of people are talking nearby, you can't hear to all of them. Okay. That is what students do in class. A number of students talking, so no one will be understand. So what is echo? It is a clear and distinct sound heard after a reflection. Perfect. So first of all, it should be clear and distinct. Distinct means when I say something, so the other person will be able to, it should go back and return back after reflection so that I can hear it distinctly. Once I say my name Arvind, so I shall be able to hear my name Arvind again. Okay. And distinctly I can understand what is the word. So that is an echo. We hear echoes generally in the hilly areas or in the closed rooms. Even in closed room, we hear the echo. Okay. So any doubts up to here?
No, sir.
Now let us try to understand the echo of sound, or what should be the minimum distance for an echo. Okay. So see the minimum distance to produce an echo. Okay. So what is the minimum distance to produce an echo? Let's see.
17.2 meters.
17.2 meters, right? So suppose you speak from this point and here you have some wall or something. From here the reflection is expected. So this is the source from where you are producing the sound. From here you produce your sound with the speaker or whatever. Okay. So this is the sound amplifier from where you are producing this. If this sound reaches the other end, okay, so the sound should reach the other end and it should return back also from there. It should return back also to your ears. So as you can see, it is traveling a distance, suppose d, from the source to the reflector, and the return distance is also d. Fine. So the speed of that sound, if I use the formula, speed equals to distance by time, right? So speed is 340 equal to distance. We do not know, that is 2d, and time taken should be more than 0.1 second. Okay. So just solve this. You will get 34 divided by 2, which will be equal to 17 meters. So the minimum distance that is required the minimum distance that is required for a person to hear the sound will be 17 meter. Okay. Now let us see how do we characterize a voice. Certain terms by which the voice is characterized or sound is characterized. So sound is characterized by its frequency. Certain things that determine about the sound you should know. Chavan Kaushik is here or not? Chavan Kaushik, are you here?
Yes, sir.
Okay. So, see, some characteristics of the sound, how we can identify the different sounds. Like we have talked of the amplitude of vibration. Understand? This is to be understood. Okay. So, what effect will have amplitude on sound?
Loudness.
Loudness? Sure?
Yes, sir.
Okay. See, amplitude will affect the loudness of the sound. You can just remember it like this. Suppose if you have a drum, okay, you have a drum and you start beating it, okay. So the harder you beat, if you beat it harder, it will produce greater amplitudes. Okay. So greater amplitudes will be produced and hence it will have a higher amplitude. Therefore, a louder sound will be produced. Okay. Siddhisri? Siddhisri? Yeah, Siddhisri.
Yes, sir.
Okay. What does amplitude tell us about the sound? What does amplitude tell us about the sound? So you are not paying attention. You are talking somewhere. Or Smith,
Yes, sir.
what does the amplitude tell us about the sound?
Sir, it shows the loudness of the sound.
It shows the loudness of sound. Okay. And what does frequency tell us?
Sir,
Mhm.
pitch.
Pitch. Okay. And pitch means, can you give an example for the pitch of the sound?
Sir, the sound is treble or hoarse like that.
Okay. So for the sound, if you are hearing any sound, so what type of sound is the shrillness or the pitch of the sound? It is determined by the frequency. Okay, like a girl's voice and a boy's voice. Okay, so the which voice do you think will have more frequency, a girl's voice or a boy's voice?
The girls.
Girls.
Yeah, the girl's voice has a higher frequency. It has more shrillness or more sharpness. Whereas a boy's sound, it is more hoarse, so it will not be much sharp. So understood these two terms, amplitude and frequency. So amplitude determines here the loudness of sound. Okay, amplitude determines the loudness, and frequency determines the shrillness or sharpness. Or you can also say pitch of the sound. Pitch of the sound. It is determined by the frequency. So frequency determines shrillness or sharpness. Now there is another thing, the timbre of sound. Can you tell what do you mean by timbre?
Like the thing which allows you to find the difference between voices.
Yeah, the timbre is the thing that allows you to find differentiate between two voices. To find the differences between the two people's voice, that is the timbre.
Wait,
So,
difference between two people's voice.
yeah, so that timbre is also called as the quality of voice.
Sir, can you give me one example?
Example of timbre. Okay, see. How do we find the timbre of a sound? Uh, okay, suppose if you produce some sound from wood, okay, and you produce some sound from a metal surface. Okay. They are identifiable on the basis of these two differences. They are arising because of their timbre, on the basis of which you will be able to identify that this is a wood sound produced from the wood and this is a sound produced from a metal surface. However, even if they produce the same frequency, then also you can produce differentiate between. For example, suppose the sound of a clap, okay, and the sound of a drum. They will be, however, even suppose, how shall I tell then? Okay, let's say, let's understand it like this. Suppose, if you know the playing of the music, any of the musical instrument, so if some singer is singing, all the instruments are being played. So all the instruments, they are producing the same frequency. Okay, they are producing the same frequency, same rhythm, but still all the sounds, they are different from each other. Okay, so that is because of the timbre of the sound or the quality of the sound. Understood
Okay.
this? Now let's see audible ranges of sound. What is the range that we can hear? Can we hear all the frequencies? Can we hear everything around us?
No, sir.
No. So see, audible range means the sound that we can hear or the frequency that we can hear. So the audible range of sound, that is from 20 hertz to 20 kilohertz. This is the frequency that we can hear. 20 hertz to 20 kilohertz. That means 20 hertz to 20,000 hertz. This is the frequency that we can hear. The maximum frequency we can hear is 20 kilohertz or 20,000. Beyond that, we cannot hear. And the frequency which is below 20 hertz, that also we cannot hear. Okay. So if you have a frequency, suppose the frequency we can hear is 20 hertz to 20 kilohertz. Now, if you have a frequency lower than this, that is called as an infrasonic. See, the sound can have its amplitude higher. It can have loudness, but if the frequency is less than 20 hertz, we will not be able to hear. Infrasonic, the frequency which is greater than 20 kilohertz or 20,000, that is called as ultrasonic. Okay. So ultrasonics or ultrasound, it finds its applications in medical, in medicines. This is also called ultrasounds. So I hope you have heard about the word ultrasound.
Yes, sir. It's used to like destroy the stones in kidneys.
Yeah, it is used to basically understand your internal organs. It is used to understand the development of fetus. So for all the internal studies, we use these sounds, ultrasonic. Okay. So for today, we stop over here. In the next class, we just go through this. It will take you 5 to 10 minutes. Okay. So go through the PDF through all the definitions.
Okay, bye, sir.
Okay, bye.
Bye, sir.
Bye
Thanks.
everyone. Okay, bye everyone. Neil? He's left.
Bye, sir. Thank you.
Okay, bye.